Hello guys, today we'll be looking about what is a k-nearest neighbor. So consider we have two features f1 and f2 for the data set D. Sorry. So and imagine this is the spread of data between features f1 and f2 where green points represent positive class and red points represent negative class. Now what k-nearest neighbor tells us is when a new data point has to be classified under a positive or negative class, what it states is let's consider the blue as a new data point, blue and orange here. So k points surrounding the blue point, all those points will be considered. Say, imagine around this blue point, if you're doing three nearest neighbors. What it does is around this blue point, it will consider three points which are nearest to it. So in this case, maybe this one, and this one are near to this blue point. Now, for the three nearest points, it would take their classes. Say in this case, all these three are belonging to a negative class. Hence, this blue point will be categorized as a negative point. Imagine we have this orange dot, orange point, and this has to be classified either a positive or negative class. Probably surrounding this orange point, we have say three nearest neighbors would be 1, 2, and 3. So in this case, there are two positive points and one negative points. So in this, the majority is a positive point. So this will be classified as a positive point. And uh, we have taken a three nearest neighbor. What if we consider a four nearest neighbor? 4 NN. So what happens in that case is like probably we may get two positive classes and two negative classes. Then it is difficult to classify a new data point under a positive or negative class. So it's always recommended in k nearest neighbors, k has to be odd number. Now, when I say nearest points, that's nothing but essentially measuring the distance. And like, how can the distances be measured? Imagine I have same the two features f1 and f2, and I have the data point x1, x2. So the distance between x1 and x2, as we studied in geometry, is uh, d equals to let this be data point be represented as x11 and x12, and this be represented as x21 comma x22. So what distance says is it is the square root of 1 second. It is the square root of, where is this cursor? It is the square root of x21 minus x11 whole square plus x22 minus x12 whole square. And this distance is nothing but Euclidean distance. And this is also called an L2 norm. So, and this is represented, this can be represented as x1 minus x2 in second norm. This is how it is represented as. And another way of distance measurement is something called as a Manhattan distance. What Manhattan distance states is it is the absolute value of distances between two data points. And this is represented as an L1 norm. So essentially, L1 norm is nothing but absolute value of distance measurement. So this is x2i minus x1i. This is the absolute value of and summation basically. I equals to 1 to n. So for all the dimensions, it takes a summation of absolute values of those distances. This example is for a classification. Means given a data point, we find the k nearest neighbors to this data point, and we do a majority vote. So, but how does k nearest neighbor work for a regression problem? So, so again to reiterate, in a classification set, we say if we have a data set D with data points xi and its labels as yi, then what we do is for the data points x1 y1 x2 y2 x3 y3 so on xn yn, and we pick the key nearest points k nearest points with that's x1 x2 x3 so on, and we pick the majority vote between yi's, right? But for regression technique, it is similar to classification, but we use mean or median for yi's. So imagine I have a regression, means I have a data set similarly like xi, yi, and say imagine I got k nearest points for a new data set, say xk, and x1, x2, x3, so on. X7 are nearest data points to this new point xk. So what k nearest neighbors for regression says is it is summation of all the yi's where I belongs to 1 to 7, and we divide it by number of data points, number of points, that is 7 in this case. So that's median. Or else another approach is to find the median. Sorry, this is the mean. Another approach is to find the median for median of say y1, y2, so on to y7. That becomes your k nearest neighbor in regression.